Use the following information to answer the next two questions. Sorbic acid is used as a preservative in wine as it inhibits the growth of fungi and bacteria. Its structure can be represented by the following line diagram. And we're also given a Ka here as well. So the first numerical response is, the value of Kb for the sorbate ion is A.B times 10 to the negative Cd. The values of A, B, C, and D are respectively, and so then you're supposed to record your 4-digit answer. So for the first part of this question here, you need to, it's asking you for Kb, and you're given Ka. So you need to understand the relationship between Kb and Ka. So you need to recall that formula, Kw equals Kb times Ka. And as I've mentioned, we're looking for Kb. So we're going to rearrange this formula here to get Kb equals Kw over Ka. So now to solve for Kb, we're just going to essentially fill in our pieces of information here. Kw, if you don't remember off the top of your head, you can find that in your data booklet, but it is 1.00 times 10 to the negative 14. And then you're going to divide that by Ka, which was given to you in the information box. So divide it by 1.7 times 10 to the negative 5. So when you do that on your calculator, you're going to get Kb equals 5.8, or we're going to round here, so it was 5.882, keeps going, times 10 to the negative 10. So we only want 2 digits here, so we're going to go round that to 5.9, 5, 9, and then times 10 to the negative 10, so 1, 0. So that would be my 4-digit answer there that I would record. Yep. All right, so now we can answer the second question, which is a multiple choice question. It says the pH of a 0.020 mole per liter solution of sorbic acid is, and then we're given 4 options. So we're asked to find pH of an acid. I want you to recognize that before we're going to find pH, we need to know the hydronium ion concentration. So that's what we are after first. So every time you're given an acid and a base, you need to ask yourself whether or not it's strong or weak, because that's going to influence the way that you calculate the hydronium ion concentration. So if it is a strong acid, we can essentially use our grade 11 techniques to solve for the concentration. But if it is weak, now we're going to have to use some grade 12 equilibrium concepts to solve. And so if we look, we know that this is a weak acid because we're given a value of Ka here. It doesn't say it's very large as it does for our strong acids in our data booklet, but we actually do in fact have a number which suggests that this is a weak acid. So to kind of orient my thinking here, I'm going to start with a balanced chemical equation. So I'll just use our structural diagram here. I'll use that in my equation. So we have that. And also in the solution, since it is an acid, there's going to be water. And now when I'm drawing in the arrow here, because it is a weak acid, I'm going to use an equilibrium arrow. It's really important that you recognize that because it's going to influence the rest of your calculation. And so since this is an acid, we know from our Bronsted-Lowry definition of acids that acids are going to donate a proton here, which means water would accept. So we're going to end up with hydronium and then the conjugate of our sorbic acid here. Oops. And I have to remove that H because it already donated it, so I'll get rid of it. And we have a negative charge there instead now. All right. So now because this is weak, we're going to have to set up an ice table here essentially to figure out the concentrations of each one of these species. So our initial concentration, our change, and then our equilibrium concentration. So initially, the question says that it is 0 0.020 mole per liter solution of the sorbic acid to begin with. The concentration of water, of course, we don't include. And to begin with, when I'm making the solution, essentially they would have started with 0.20 mole per liter of the sorbic acid, and hydronium in this ion would be 0. Now our change, well, after it establishes equilibrium, to establish equilibrium rather, we know that we're going to have to add a concentration here, add a concentration here, and then we would lose some here. And then our equilibrium then would be 0.020 minus x here, and then x and x. So now we're going to set up a Ka expression, Ka because it's an acid. Again, really important to recognize that. Don't try to use Kb here. Even though you did calculate Kb in the first numerical response, that's okay. Because we're talking about an acid, we're going to use Ka here. So Ka equals, so we've got x times x over the concentration here of our acid. And now I'll just plug in our values. So for Ka, we have 1.7 times 10 to the negative 5, and that equals x squared over 0.020 minus x. And now we're going to make this simplifying assumption here. So to make this simplifying assumption, we're going to assume that the value of x is so small, which means that 0.020 minus an incredibly small number is essentially just going to be 0.020. And according to the curriculum, you will always be able to make that assumption in this course. So now we're going to rearrange here to find what x is. So we're going to have here x squared equals 1.7 times 10 to the negative 5 times 0.020, and then we'll square root both sides. And when we do that, we're going to get our value for x, which is approximately so when you do that, you're going to get a value for x of, and again, keep all your decimals here in your calculator. So I would keep all of those values for x because I'm not done my calculation. What I've calculated at this point is my concentration of hydronium, but I actually want the value for pH here. So now to calculate pH, you're going to go pH equals minus log of your hydronium ion concentration, which is minus log of x. So when you put that value for x into your calculator and take the negative log of it, you're going to get approximately 3.23, which is option, it's incredibly hard to read at this point, but it is option C there, 3.23. So I know that C is my final answer.